The next talk is by Fabian. Great to have you here. Fabian is Director of Data Science at XING New Work, and he's going to talk about recommender systems at XING, the third talk in a row about recommenders. Have fun. Enjoy.
Yeah, thank you very much. Yeah, my name is Fabian. I'm actually working for XING already 10 years. Didn't expect that when I moved actually to Hamburg 10 years ago. But anyway, so I started building up the recommender systems and still work on recommender systems. And yeah, in this talk, I introduce a little bit recommender systems at XING, and then yeah, talk about, let's say, also automating processes regarding recommender systems. And at XING, there are actually different types of recommender systems. So there are recommender systems for jobs, recommender systems for contacts, but also for other types of items, so for events, groups, companies, news, and so on. And XING itself is essentially like the German LinkedIn, right? So for those of you who do not know XING. And the recommender systems at XING, they in the end are just a REST service, like where you make a HTTP GET request with a user ID, and then you get back list of recommended items. Usually this list comes then, is ordered, right, and comes with some scores representing how relevant the item is regarding or for the user, or the estimated relevance, and also some reasons, high-level reasons why we think this item is relevant to a user. And yeah, that's it. And then recommendations are rendered like this. This example is for job recommendations. And the high-level architecture of the recommender systems at XING is always the same. So we have some core recommender engines, and yeah, almost for all of the recommenders at XING, it's always an ensemble. So we do not bet just on one recommender strategy, but usually we have several recommenders running in parallel and trying to predict items that are maybe of interest to a user. And like these recommender agents, they form the basis, and then on top we have filters and in the end also some ranking that we apply. And these filters, I mean, there are some recommenders that have like 25, 30 different filters. Some of these filters are maybe super simple, right? For job recommendations, for example, we filter out jobs that the user has seen already, or has bookmarked already, or applied to already. And then there are also some more sophisticated filters that would maybe try to predict how would the user rate a given item, and then, okay, it's on a 5-star rating scale, and if this predicted rating is below a certain threshold, we filter out the item. And in the end, all the items that make it through the different filters, they are ranked. And for this ranking, it's also sometimes yeah, not only one ranker that is applied, but sometimes we have lightweight pre-re-rankers, right? That would, because sometimes you have like 500 items that you need to bring into an order, and then we have like a lightweight ranking model that is applied first, and then a second, more heavy model that is applied afterwards. And these things, these recommendations, for almost all of the recommender systems, they are computed on the fly, right? So we would not sometimes maybe there are a few use cases where we pre-compute also recommendations, but that's not the norm. So almost in all the settings, we compute recommendations live. This means when you get a request and then answer 150 milliseconds later, like this REST service that delivers recommendations, I mean, lots of things have to happen within these 150 milliseconds. And one example I brought, I mean, just to recap, so there are different core recommender systems engines. We typically have at least one content-based strategy in there and one collaborative filtering engine as well. And yeah, I brought one example of a recommender system component, and it's this one we call actually Outlier Theater. It's something for job recommendations or a component of the job recommender. Job recommendations is actually a super hard problem because people freak out if they get a bad job recommendation. So if you recommend an internship job to a CEO, I mean, the CEO gets pissed and will, call our customer support team sometimes or things like that. So yeah, this outlier filter is essentially trying to filter out recommendations where people freak out or which have the potential that people would tweet about it and say something bad about XING, or how stupid are the data scientists at XING, why do they have so shitty job recommendations? And for this outlier filter, we actually described it already high level. The task that this filter has to do is, like, given a user, given a job posting, try to predict on a 5-star rating scale, how would a user rate the given item? And for this, actually, we have some training data, because in the past, or for 3-4 years, we actually had explicit ratings also in the system. So people were really asked, like, hey, what do you think about this job recommendation? How relevant is this to you? Is it a good match? Yes, no, or not yes, no. They were then asked to rate on a 5-star rating scale. And this training data, or this data, we still use for training. Plus, we actually also use implicit interaction data, because right now we do not have these explicit ratings anymore on the platform, but we learned how we have to interpret the implicit interactions like clicks, bookmarks, apply interactions. So how these actually correspond to these explicit ratings. And once such a model is then applied, predict rating for a given user and posting, we filter out the items that are below a certain threshold. So if we predict that the item would be rated with 1 star or something like this, we would filter it out. And for this model, or for this filter, we use XGBoost, which is essentially also an ensemble of decision trees. And we have, for this outlier filter, I think we have around 120 features in place. There are things like content-based features. Does the job role of the user match the job role of the job posting? Or what's the distance between the geographical distance between the user and the job? And how far away is the career level, like the seniority level of the job posting compared to the seniority level of the user? But there are actually also some collaborative features in here. They're not on the slide here, but. And XGBoost is, by the way, also is somehow, or for some parts of the recommender system, it's like our universal weapon. We also use it, for example, for ranking models. And one thing that we have to, for this outlier model, have to take care is, okay, on the one hand, we predict a rating, but then on the other hand, we have to decide, okay, when do we now filter out recommendations? Here we use something that we internally call the filter onion. And this onion tells us essentially, if I would put the threshold to a certain value, like 2.5 or something, what's the fraction of good recommendations that I would lose? And what's the fraction of bad recommendations that we would lose? And we try to essentially find here the maximum that we filter out a lot of bad recommendations, but still do not throw away too many of the good recommendations. And in the end, it's just one example of a machine learning model that comes into play in recommender systems at XING. There are other ones, right? So in the core recommender engines, we also make heavy use of embedding models. And also for ranking, we use machine learning models, but then we also have, let's say, a couple of models that would predict missing values, or that try to, if people didn't specify what the current job role is or what the current seniority level is, then we have models that try to predict this. And these models, they actually need to be retrained every now and then, right? Because if you don't do this, then this has a negative effect on the overall system also. So the model, the quality of the model will degrade over time. And here's a real example also of one of the recommenders where the process for retraining the model was not properly working for actually a couple of months. And what you saw is that we had a relative decrease in click-through rate by more than 8%. This was not good. And the moment we realized this again and retrained, we were able to recover this. And I brought some reasons why machine learning models are degrading in quality. I think the root cause is always that the data characteristics change, right? And these data characteristics change maybe sometimes because the UI is changing, right? So visualization of recommendations changes, and therefore people show different click behavior. Sometimes it's also the model itself that implies that data characteristic change, or that imply that users interact differently with the system. So, for example, what was the one thing that we actually had one time in members, so in the contact recommender, was that we deployed a new model that would favor a lot contact recommendations that have a profile image. And this actually had a big change on how people interact then with these recommendations. And actually, next training was then also, or when we deployed a new model or trained a new model, this led then also to some issues because data was biased quite a lot. So profile picture actually was not considered anymore as very important because actually all the recommendations that were shown, or most of the recommendations that were shown and interacted with, had a profile picture. Anyways, but it's the other thing, third point, is actually that the item inventory. So if this changes, this can also lead to changes in the data characteristics. And also the data collection may change, right? So there are new tracking sources that are added, or maybe a new browser plugin that gets popular and blocks tracking. And then, so the data that you train on will change, or the data that the models are acting on will change. And retraining, in the end, should not be a process done by or triggered by a human cron, but it should be automated, right? And automating this, I have here one example. So what does actually retraining mean? So in the scenario we are in, we actually have, on the one hand, let's say, batch processes that train or retrain machine learning models, and then we have the recommender service that is applying a given model. And retraining, in the end, just means that we update a file, right? The serialized ML model. We actually also use ONNX, which was mentioned in the talk before, for serializing the models. And if we go through these things, first of all, the automation of these processes can only happen if you are also able to construct the ground truths of the data, right? Because I said one of the key reasons why you need to retrain a model is that the data characteristics change. This means you need to then have a training data set that is also operating, that is formed based on this new, on recent data, right? And for us in the recommender systems, but also for search, where we also have machine learning models, yeah, we have luckily some ways to automatically construct the training data. For example, in search, but similar to ranking, we would look at which items did we show to a user, and then which items did the user positively interact with. In this example, the user, yeah, we showed this gray item to the user and then the light green item to the user. And actually, the gray item was ranked above the green item, but the user clicked on the green item. So we conclude that this green item is more relevant to the user compared to the gray item. And then one thing that is also important is, like, once we retrained a model, it's one thing to optimize the model against the training and test, or training data or development data set, and then to validate how the performance is against the test data. But it's another thing to actually check what the impact of the retrained model is on the overall system. And one very simple procedure that we usually do is that we would take the new model, select 50,000 random user IDs, and then actually call the recommender service. One time we call the recommender service using this old model, and one time we call the same recommender service using the new model. And then we just check how different are the recommendation lists that are returned by this service. So what's, for example, the overlap within the top 10, or what's the case similarity between the top 10 recommendations. And if we see that there are actually no changes, then, okay, there's, for example, no need to do an A/B test, right? But this is one step that also needs to be automated. And usually at the end of such a process, we would write an email to the developers, including then the proposal, like what to do next. And in case we see that the new model delivers or has an impact on the entire system, that then the recommendation lists are really different, then there's a call for, hey, we need an A/B test. We know that the newly trained model implies bigger changes, so we need to check, are these changes actually good or bad? Does it in production then lead to a better, more relevant recommendations, to better user experience, yes or no? And this we typically do with A/B tests, but in the past also went to use interleaving tests, where you would, for interleaving, it's essentially that one user gets recommendations from both models, right? So you would, for example, in a search result, you have your list of items that you return, and then one list is coming from the old model, one is coming from the new model, and you zip this essentially. And this is, whenever this is possible, interleaving, it's definitely something to prefer, because you get way faster significant results. But still, for us, most often, I think it's A/B testing that we do. And these 3 steps can be automated. This looks essentially like this. So the truth is that it cannot always be, everything cannot be automated. So, but the lucky or the happy path can be automated. So when we do the retraining, first check is, do we have the same or better performance on the test set? If yes, we can go on, but if not, we actually have to investigate. So then it's already automation stops, let's say. The happy path, we are on the happy path, so we have the same or better performance, then we have to check then with this offline checks. Do we observe big changes on the entire system? Yes, no. If there are no big changes, we just deploy the new model without an A/B test or without online evaluation with interleaving, and all good. But if we see bigger changes, then we have to do an online evaluation and then also do run the A/B test again. And for A/B test evaluation, also something that can be automated. It's then at the end we need to check: do we have then the same or better performance during the A/B test? If yes, all good, we use a new model. But if not, again, a human has to intervene, and we check, okay, why is the performance worse, right? And one last slide that I brought is just that, I mean, I think it's not that simple to always say, like, okay, you have to automate everything possible, right? So, because there is, of course, there are some costs attached to automating these processes. So, particularly if you do this the first time and do not have found, let's say, your standards yet, or your best practices, how you typically do this, how you typically automate these different processes. And therefore, let's say, for the automation, usually you have a lot of more costs at the beginning, so it takes you time. Also, the ground truth, I mean, even if you have, let's say, from tech stack perspective, you have your best practice, still you need to be able to automatically create your test set and training set. And doing this right, this is also difficult, right? So, and it's something one has to invest a lot of time and do this very good, because, of course, if you train against the wrong objectives, or if you have flaws in the way you create your training and test data, this is not good. But usually, once you would go through this, once you are able to automate, I mean, then your life, of course, gets better, because you don't need to set a reminder to every 2 weeks retrain a model and then have an awful afternoon. And yeah, with this, I'm actually done. So main message of this talk is that the machine learning models, I mean, they are part of the production code, right? So the models themselves, but also more importantly, the code that generates these models. And therefore, we should treat these models and the code that generates these models also as production code. So, and that's it. Thank you very much.
Thank you, Fabian. Esther, there are no questions yet from the audience, but there's one at least. Maybe you can. You really have. Okay, go ahead, please.
You showed that if there are no big changes, you prefer the new model, and I would like to ask why. So, like, the new model is always.
Maybe you can repeat the question.
So the question is, like, if there are no big changes, we take the new model. So it's important to emphasize that this is just focusing on retraining a model. So it's just all the features stay the same, and it's just retraining the model. So essentially, no code is changed. This means, like, I mean, if the performance, I mean, it's just the code. We want to continue to use our code. That's essentially that's why also with same performance we take the new model. So we would have a bad situation if, for example, for some reason our old model is performing better, but let's say it's we cannot retrain it because there will be the time that we add new features, and then you anyways need to retrain or train this model again, right? That's it.
And do you have another question? Yeah, the second one. Go ahead. Sure.
Based on which metrics do you decide if you have to retrain? So do you monitor your matrices, or it's just time-based every 2 months? Or? It's time-based, but if we don't do so, one thing that we are currently trying to actually get better in is monitoring the data quality of the input sources of these machine learning models. And then I guess that this will become at some point then also a trigger for retraining. So that, okay, you can say once a week you would retrain a model, but if you realize that there are big changes in the data that the model uses, that certain distributions suddenly start changing, then that's the time when you should retrain, maybe, depending also on the volume of data that you have, because let's say the moment you realize, hey, data characteristics starting to change, you also need to be careful that then, you want to be able to automatically create your training and test data, meaning that you will need also a certain volume of data so that you can create it. But that's at least what we are investing in, that we try to monitor better the data quality of the inputs sources from machine learning processes.
Okay, thanks again, Fabian, for the great talk. Yeah.